So it gives me great pleasure, and please give a warm round of applause to Nikos Kapetanos from Yodec. His talk will be titled, Building an IoT Software as a Service Using Python. Welcome, Nikos.
Hello. Can everybody hear me?
Is Nikos'
Not really?
Yes.
Okay. Hello, my name is Nikos Kapetanos. Get this one. So today we'll talk about how we're going to build a software as a service that also has an IoT part. A few words about me. I studied at the Computer Engineering and Informatics department at the University of Patras. I have some previous experience with Java, but also with microcontrollers and embedded devices, mostly as a freelancer. Almost 4 years ago, I joined Yodec and discovered the wonderful world of Python. Most of my day job requires me to write code for Django, but also program on the Raspberry Pi with Python, and some parts are C. So enough about me. Let's get to the presentation. What we're going to talk about. More or less, we're going to talk about how these three guys managed to use a rather common software stack, a Python software stack, to build a software as a service that sells at almost 68 countries and have thousands of customers around the world. So we built Yodec. Yodec is a complete digital signage solution, but any of you aware of what digital signage is? Well, not really. So what is digital signage? Wherever you see a screen showing some advertisements or billboards showing, let's say at an airport, flight information data, there you have digital signage. You can also find them at companies showing dashboards of KPIs. You can also find it in offices showing various adverts. Yeah? Ah, well. Okay. So Yodec is a complete digital signage solution. You can manage your content on a web application and manage your devices. It follows the software as a service model. So you pay a monthly fee or an annual fee. We have implemented the player for the Raspberry Pi, which is an embedded device. So you take a Raspberry Pi, connect it to a monitor, and you can manage your content from the web application. Since we have Raspberry Pis that are installed anywhere in the world, we could say that Yodec is an IoT software as a service in its nature, since the screens are the things. As I said earlier, I work with Python, so most of Yodec is implemented with Python. Let's see some of the technologies used for Yodec. As I said earlier, the player part on the Raspberry Pi uses Python. The web application is based on Django. We use Postgres. Redis for caching. The front-end part uses technologies I'm not really familiar with. jQuery, Bootstrap, Backbone.js, etc. And the IoT Hub part that we're going to say more later is composed of Crossbar IO, which uses the WAMP protocol, Redis, and Postgres. Before iterating the building components of Yodec, of an IoT-based software as a service, we first have to look at the lean way of doing business. The lean startup instructs us to build a product really fast, measure how the users are using the product, and then come up with ideas to enhance the product, change the product in order to be better for the customers. This cycle should happen always, but the key word here is that each cycle should be happen fast. So what better tool than Python to have a rapid development? Now let's, Let's go through the basic building blocks. Most of you are probably aware of these building blocks. First and foremost, we need a web framework for our application. We chose Django. It's the most popular Python framework. It fits our need for rapid development. It also follows the Python paradigm that batteries are included. So you get the web framework, but you don't have to reinvent the wheel. You actually have a lot of cool features along with Python. You have user management. Users can create new user accounts. You have email verification, reset emails, etc. Django comes with a nice ORM. It gives you the opportunity to skip SQL. So in fact, you interact with your database using a nice Python framework, a nice Python API. But if you need, for extreme cases, highly optimized SQL queries, it would be better if you go for raw SQL queries. Django does not prevent you from doing that. You also have a nice migration mechanism for rolling out changes to your database and tracking them. It also includes a powerful templating engine, so you feed data to your templates and they're rendered. Okay. Some technical difficulties. Thanks. You feed data to your templates and you present the user with a nice web page. Something that's not referred here, but it also includes a nice testing environment. So it uses the standard unit test of Python and lets you write your test and test your application. Moving on, we're going to need a database for your application. So Django supports most of the major databases. It supports Postgres, MongoDB, MariaDB or MySQL. Uses MariaDB better. OracleDB and SQLite. SQLite is used mostly for tutorial purposes, although there are some online services actually using SQLite. Don't know why. Most of these databases are also provided by all major cloud providers, so you can save some time during your application development and have a database ready to use. Moving on, we're going to need Celery to build our application. So Celery is a task scheduler. It's mainly used for running tasks in the background, tasks that don't fit exactly in the time frame of a normal HTTP request. For example, a client requests for a report. So instead of having the client wait for about, let's say, half a minute, 30 minutes, 30 hours, who knows how big is this report, the client asks for a request, you say, okay, your request has been queued and will be generated later. And you run the task in the background, and when the task is ready, you send a notification to the customer, or you can send them an email, etc. You can run background tasks at specific intervals, let's say every day at 5 o'clock, or you can run a task once. Let's say you run this task 5 minutes from now. Running recurring tasks is really good for, let's say in our case, offline device notifications, backups, and also, as I mentioned earlier, user reports. What is important here is that the code runs on the same environment as the rest of the Django code. So this means that you don't have to use any specific Celery APIs or anything to communicate with your application. You just use your standard Django code, and you have your perfect ORM, you have your templates, you have everything. And you go ahead and work. Celery also supports multiple queues that span across multiple nodes. So you can have multiple physical machines or VMs and distribute the work around amongst them. That's really nice, and so it works almost seamless. No need for extreme configurations. Now that we have a framework, we have a database, we have Celery, we need to serve all the stuff. We need to have a web server. So we're using Nginx to serve our static files. It's a highly performant web server. It has some nice features such as rate limiting. So you can rate limit, let's say someone tries to brute force your login page. So you can rate limit this. You can also use Nginx for TLS termination. So the HTTPS stops at Nginx, and then the request is proxied internally to your application server. For the application server now, we're going to use UWSDI. This is the application that runs our Django application. UWSDI supports not only Python, but other languages that support the WSDI protocol. UWSDI has some cool features, such as spinning up new worker processes to face some load spikes or downscale if it needs to be. It also supports reloading your application in a good way, so you don't have any major downtime. So you don't almost have no downtime. If we go back to the original graph, we're going to see, we talked about understanding users, see what the user wants. So we're going to talk about some services needed to build an IoT software as a service. UserVoice is one of them. It actually helps us to get feedback from users. So, of course, we get tech support tickets. A cool feature is the idea section, where users can submit their ideas and other users can vote for them. So you have a rough estimation of what your user wants, and you can go ahead and implement those features. UserVoice has a cool front-end widget. If a user has a problem or needs to learn something they don't know, they just search at the widget. They are suggested a few support articles, and if something does not quite work for them, they can always reach out for you. Also, UserVoice supports customer satisfaction polls. So when the user logs in or when they're using the application, a small div pop-ups and says, hey, you like Yodec, you like our service, what do you like to see? Of course, there are alternatives, since UserVoice has changed their pricing policy. Intercom, Zendesk, Freshdesk, etc. Moving on, we have Hotjar. Hotjar is quite intrusive, actually. It records the user session and gives you the ability to play back that session and see exactly what the user was doing. So, in fact, it's quite intrusive, but the key point here is that you can't actually determine who is that user. So you see anonymous user sessions. You get, with Hotjar, you can get nice heat maps. So you can see how the user interacts with the application, what buttons do they push. If a button is not used anymore, why not just remove it? And it also is GDPR compliant. As I said, the sessions are anonymous and you can't really know who's who. So what's missing? We have our application, we have a few other services to help get data from the users. What's missing? Money, of course. We need to gather money. We need to get money from our customers. So this is where Stripe comes in. It allows us to have recurring payments, since we're a software as a service. You can also have one-off payments. It also keeps customer credit card data. It's something that you don't have to do it yourself and never should do it yourself. It also has a great, easily integrated widget for your UI. It supports webhooks. So you get an HTTP request wherever something happens on Stripe. Let's say a new payment, a recurring payment, a customer updated their customer data. Since we're using Django, there's an application for that. It's called Django Stripe. It wraps around almost all Stripe API. It gives us nice callbacks for the webhooks. And all data are readily available on our database, except credit card data, of course. So you don't need to always ask the Stripe via their API for customer data. Of course, again, alternatives, Braintree, PayPal, etc. So that's it. I'm done. No. I'm kidding. I'm kidding. So we talked about an IoT presentation, an IoT software as a service. Okay, so where's the IoT part? As I said earlier, Yodec in its nature is an IoT service that distinguishes us from other software as a service. So let's talk about that. Let's introduce the WAMP protocol. WAMP, as its name suggests, is a web application messaging protocol. It allows easy communication between things, like they're called components from the protocol. These things can be code, devices, even browsers. In our case, screens, things. It is registered as a WebSocket subprotocol, so we're talking about standard stuff here. It also has bridges for HTTP and MQTT, so if your device or a web client can't talk the WAMP protocol, they can interact with MQTT or HTTP. So why do we need a new protocol? Wasn't HTTP enough? It actually wasn't. So HTTP provides a one-way communication. So the client wants something, it asks the server returns it to the client. So if the client, if the server needs to say something to the client, what happens there? Again, the client needs to ask for it. So it needs a request, and then the server will send a response. But now, you don't have actually a two-way communication, you have one-way communication. So this is where WebSockets come in, where you have a direct continuous connection with your client. And we use the WAMP protocol to perform the communication. Let's talk about Crossbar I/O. Crossbar I/O is a main implementation of the WAMP router. It actually is one of the many implementations of a WAMP router, but the guys that created Crossbar I/O also contributed to the WAMP protocol. So it implements most of the WAMP features. The main key here is that all communications happens through the router. So if a device needs to send a message to another, it sends it to the router, and the router decides where to forward that message or not, depending on depending on the permissions. So for the router side, we have Crossbar I/O. For the client side, we have Autobahn. It's one of the many, again, implementations for the WAMP router, for the WAMP protocol. Also, the guys that wrote Crossbar I/O also wrote Autobahn. That makes sense. It, of course, is available in many languages, Python one of them, JavaScript, so you can run, you can interact with the WAMP protocol from your browser, C++, Java, and C. Let's see what WAMP gives us. So we have publish and subscribe. Components, clients, as we said, components, can subscribe to certain topics, and other components can publish messages to those topics. So they achieve communication. It's important to say here that these messages don't have a response. Let's say I send a message and I'm not aware that anyone listening to that topic got it. There is support for that, but it needs an advanced API. We also get nice RPC calls, remote procedure calls. Each component can register an RPC, so I'm component A, I have a function that adds some numbers, for example. Other components can call my procedure, give me the two numbers they want to be added, and I run the addition and return the result to the caller. Again, all communication is routed through the WAMP router. Let's see a little bit about the Crossbar I/O router. The configuration is solely composed of a single JSON file. The JSON file defines authentication, roles, authorization, transports, and more. Let's say, let's continue. Authorization dictates what each component can call, what each component can register, what each component can actually do. For example, let's say the component com-example frontend, or any topic under that URI, are allowed to call this URI and subscribe to this URI and publish to this URI. But of course, only some other component can register a topic under this URI. What is really cool here is that we can have dynamic authentication and authorization. And this happens using the standard component. A component can perform the authentication and the authorization in a dynamic way. So, in a sense, everything is a component. Let's see a simple example. I have a pointer. Sure. We have this component that actually subscribes to the hello topic, and also publishes a message, hello world, my name is component 1, let's say. So any other components that have subscribed to this hello topic will receive the message. So another more complex example, we have a component that actually gets the temperature for a Raspberry Pi, sorry. And if it sees that the temperature is over 75 degrees, it calls a remote procedure and called notify owner. And this procedure will actually send a message, an email, to the owner of the Raspberry Pi and say, hey, your Raspberry seems to be a little bit overheated. Have a look. Okay. This is the other side of the previous example. This is a server side. So this is actually the component that registers the notify owner remote procedure call. And when a device calls this remote procedure call, it prepares an email and sends it. So we have a working Django application, we have a working IoT hub, we have a working crossbar I/O router. How do we connect together? So in this case, we can use HTTP bridge. The HTTP bridge provides a way for the Django application to communicate over HTTP with Django, with the router. So we can have direct communication with the devices, in a sense. So a client asks for a device to reboot, Django sends a request to the IoT hub, and the IoT hub instructs the device to reboot. But since we mentioned that we can have WAMP directly from the browser, we could also use the browser as a component. So in this same example, the client could ask directly the WAMP router to communicate with the device and reboot it. There are a few benchmarks for Crossbar. Since it is based on twisted asynchronous framework, it's quite performant. Not have enough time to go through this. That's it from me. Let me know if you have any questions.
Thank you very much.
Thank you.
All righty, let's see. Do we have any questions from our... How is Celery used? Do you use it for web testing?
Oh. So we use it mainly for background tasks, not for testing. We use it for offline messages. We use it for tasks to offload our web server. So if a task takes 2 or 3 or 4 seconds to communicate with another service, we offload it to Celery. We also use it for database backups, etc.
Any more questions we have? There we are. Dimitri.
If for any reason the team decides to add a new option other than Raspberry for Yodec, would that make your life very hard or just hard?
Since I know you. Yes, it will make it hard. But it's easy to implement when we talk about only for Autobahn and crossbar I/O. It's easy to integrate any embedded device, really. Yes, but the playback part of our player is another thing.
Okay, what is dynamic authentication you're mentioning?
Yeah. So, as I said earlier, all the configuration for the WAMP router is a static JSON file. This means that anything, any component that will connect to the router needs to be described in that file. So, sorry. So this means that when you have to add more components, you need to restart your router, which is a lengthy process if you have tens of thousands of devices. So you have a component. When a device tries to connect to your hub, you have a component that checks that this device is permitted to join the hub. So why not Flask? Oh, that's a nice question. I think my main answer would be that batteries are included on Django. So with Flask, we have more permission, let's say, but you have less features. Okay, so using UWSDI versus JUnicorn. It's a matter of a selection, really. The project was already set it up with UWSDI, so we stick with it. So, WAMP versus MQTT. That's a nice question. Since MQTT is, I believe it requires less memory, you can use it for less performant devices, but the Raspberry Pi is quite performant enough, so we use WAMP. If you need to, but of course that does not restrict you. You can use MQTT to connect to Crossbar I/O.
Very good. Thank you very, very much.
Thank you.